Welcome to online classes. Today we have to discuss some application of determinant. That means we have to apply use of determinant to find the area of the triangles. And using determinant, we have also find the collinearity test of a triangle. Okay. So first we apply or we use the determinant to find the area of the triangle. So if a triangle have three vertices, that is x1 y1, x2 y2 and x3 y. Suppose a triangle ABC having three vertices, that is x1 y1 and x2 y2, b of x2 y2 and c of x3 y3. So using determinant, we have to find the area of the triangle. Okay, but we have already know how to find the area of the triangle. As you know, area of the triangle is half into base into height. Okay, but here we have to find the area of the triangle using determinant. So here in this triangle ABC, coordinate are A of x1 y1, b of x2 y2 and c of x3 y3 are the vertices of a triangle. Okay, now we have to find the area of the triangle using determinant. As you know, in class XI, that is first year, area of the triangle ABC having three vertices, that is A of x1 y1, b of x2 y2 and c of x3 y3 is equal to half into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. So this is the formula that we have learned in class 11, that area of the triangle ABC in coordinate geometry. Okay, so here we write area of the triangle ABC is equal to half into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. But here we can write half of x1 into y2 minus y3. Now we take changing the sign of x2. That means minus of x2. That equal to, if we take common minus, so here we can write y1 minus y3 plus x3 into y1 minus y2. Okay. So why we changes the sign of the middle term? Because we can convert it into determinant form. As you know, in rows or column, in first row or first column, the sign of the rows, that is plus minus plus. So we changes the sign plus minus plus. Okay, now we can write in the form of determinant. That means you can see here x1, x2 and x3. So we can write in first column, that is x1, x2, x3, and in second column y1, y2, y3, and the third column must be 1. If we evaluate this, suppose half into, if you expand this determinant using first column, then you can get the result of the above. So if we check the values, that is half of, if we expand this determinant using first column, that is x1 into, if we deleting rows and columns, then y2 minus y3 here, minus of x2 into, if we deleting these values, then we get y1 minus y3, and plus x3 into, if we deleting these values, then we get y1 minus y2. So that is the formula, or this is the method of determinant to evaluate or determine find the area of the triangle ABC. So now take an examples using determinant. So using this rule. We can take an example here. Suppose using determinant, okay, using determinant, prove that the points A of 2, 3, B of 5, 4 and C of 7, 6 of a triangle or form a triangle find the area of triangles. Okay, so here we have 3 points or 3 vertices, that is A, B and C. We have to find the area of the triangle ABC using determinant method. So using this formula, we evaluate to find the area of the triangle. Okay, so you can see here there is the solution. So given A of 2, 3, that means we can take the left, that is x1, y1, okay, and the second point B of 5, 4, and the last one, that is C of 7, 6. So here you can take left, that is x1, y1, and there is the x2, y2, and that is x3, y3. Okay, as you know, area of the triangle ABC by determinant method, that is half of x1, x2, x3, y1, y2, y3, 1, 1, 1. So this is the formula to evaluate or find the area of the triangle ABC. Now we have put the value of x and y. Okay, so here half into, if we put the value of x1, x2, x3, that is the first value of all these points, that is 2, 5, 7, and the second columns, that means 3, 4, 6, and the third column remains same, that is 1, 1, 1. Okay, now you have to evaluate or we have to expand. We have to expand these values, that is half into, if we evaluate using first column, that the sign of this value is 2 positive, so we take 2 into, if we take this value, that is 4 minus 6 minus 5 into, because we take expansion using first column, so here 2 and then 5, the sign of this value is negative, so minus 5 into these values, so here 3 minus 6 plus 7 into 3 minus 4. Okay, now we will expand these values. 4 minus 6, that is minus 2, minus 2 into 2, that is minus 4, 3 minus 6, that is minus 3 into minus 5 plus 15. Okay, and the last one, that is minus 1 into 7, that is minus 7. So here half into minus 4 minus 7 minus 11 plus 15, that is 4. So if we cancel these values, so we get 2. And 2 is the answer of the given questions, and you can write the units. So here if you find the value of area, so you can write here 2 square units. Okay, so in this question, area of the triangle ABC is 2 square units. So this is the process to find the area of the triangle using determinant. Okay, next one, that is application number 2, how to apply determinant in collinearity test. So the second one is use of determinant use of determinant to determine the collinearity of 3 points. Collinearity of 3 points means 3 point lies on a line. So that is the collinearity. Collinearity means 3 points. Suppose we take 3 points A, B, C. Or collinearity means 3 point lies on a line. Suppose A of x1, y1, B of x2, y2, and C of x3, y3. So, how to test collinearity? That means 3 point lies on a straight line using determinant. So here we take 3 points A of x1, y1, B of x2, y2, and C of x3, y3. So you can write 3 points A, B, and C will be collinear. If, as you know, if 3 points are collinear, that means area of the triangle ABC must be 0. So 3 points ABC will be collinear if area of the triangle ABC is equal to 0. So, as you know, in first application, that is area of the triangle ABC, the formula of area of the triangle ABC in determinant form, that is half into determinant of x1, x2, x3, y1, y2, y3, 1, 1, 1, that is equal to 0. So here, if we take half to the right side, so we get x1, x2, x3, y1, y2, y3, 1, 1, 1, that is equal to 0. So this is the formula, or this is the determinant form to check or verify collinearity of 3 points. So if we check 3 points are collinear or not. So now taking examples, check 3 points that 2, 3, 5, 4 and 4, 6 are collinear or not. So we have to check 3 points are collinear or not. So here is the solution. So we take 3 points, that is A of 2, 3 and B of 5, 4 and C of 4, 6. Okay. Now we have to check that these 3 points are collinear or not. You can write here using determinant method. Okay. That means we have to verify only determinant method. So many methods have to verify the 3 points are collinear or not. But here we have discussed collinearity of 3 points using determinant. Okay. So first we have to write the 3 points A, B, and C. Then collinearity test means 3 points are collinear if the determinant will be 0. The determinant means x1, x2, x3, y1, y2, y3, and the third column is 1. If this determinant equal to 0, that means the 3 points are collinear. So now we have to check them. So we take LHS of this part, that is x1, x2, x3, y1, y2, y3, 1, 1, 1. Okay. So now we have to put these values, that is here you can see 2, 5, 4, the value of x1, x2, x3, 2, 5, 4, and this second column is 3, 4, 6, 1, 1, 1. So now we have to evaluate these values. 2 into 4 minus 6, okay, minus 5 into, if we derive these values, that is 3 minus 6 plus 4 into 3 minus 4. So now you have to evaluate these values. 4 minus 6, that is minus 2, minus 4, minus 3 plus 15, that is minus 4, minus 4. Okay. But here you can see minus 8 plus 15, that is plus 7. Okay. And this value is not equal to 0. But here, if 3 points are collinear, that means must be the determinant of this expression must be 0. But here you can see this determinant will not 0. So 3 points are not collinear. So we have to verify or check that 3 points are not collinear. But if the determinant is 0, then the 3 points are collinear. So this is the procedure to check 3 points are collinear or not. So this is the application to verify collinearity and area of the triangle ABC. Now elimination of, next we have discussed how to eliminate x, or we can write alpha and beta are variables, alpha and beta from the equation. So here we have 3 equations, that means a1 alpha plus b1 beta plus c1, that equal to 0, and another equation a2 alpha plus b2 beta plus c2 is equal to 0, and the third one a3 alpha plus b3 beta plus c3 is equal to 0. That means we have 3 equations and we have to evaluate these values alpha and beta, or we can take x and y, or we can write here, okay, alpha and beta form, because it is similar to the questions having the exercise of these books. So here you can see 3 equations, so we take equation 1, 2 and 3. So if we have to evaluate alpha and beta, we take from 2 equations, that is equation 2 and 3. So from equation 2 and 3, using cross multiplication method, here we apply a method we evaluate alpha and beta. As you know, alpha and beta. So first alpha by, beta by, and that is 1 by. This is the procedure to evaluate the cross multiplication method. Okay. So we take the last two equation, alpha, beta, and 1. So if we evaluate alpha, then we can ignore alpha, the value of alpha. So in cross multiplication, that is B2C3, B2C3 minus C2B3. And the value of beta is, so if we ignore or if we when this is the value of B, so we can take the right side because it is the middle term, because it is sign of indeterminate, plus minus plus. So we changes the sign, C2 minus A3 minus A2 into C3. Okay, and the last one, that is 1 by, because it contains constant, so we take 1. So 1 by, that means we have to ignore, that is C2 C3. So A2 B3 minus B3. So all these expressions we have to cross multiplication left to right, but in the middle we can take right to left. Okay, so this is the procedure or formula by cross multiplication method. So here alpha by is, beta by, and 1 by. Now if we compare it first and last, then we get result alpha is equal to, if we multiply, that is B2C3 minus C2B3 by A2B3 minus B2A3. This is the value of alpha. And the value of beta, that is, this value is multiplied to the right side, that is C2A3 minus A2C3 by A2B3 minus B2A3. Okay. So this is the value of beta. So with the last two equations, that is equation 2 and 3, from equation 2 and 3 we find the value of alpha and beta. Now this value we have to put in equation 1. So putting the value of alpha and beta in equation 1, we get. So here first equation is A1 alpha plus B1 beta plus C1, that is equal to 0. That implies, now we put the value of alpha and beta. So A1 into alpha, the value of alpha is B2C3 minus C2B3 by A2B3 minus B2A3 plus B1 into the value of beta is C2A3 minus A2C3 by A2B3 minus B2A3 plus C1, that is equal to 0. So now we have take LCM, that is A2B3 minus B2A3. So here the value is A1, in the numerator the value is A1 into B2C3 minus C2B3 plus B1 into C2A3 minus A2C3 plus C1 into A2B3 minus B2A3. That is equal to 0. So A1 into B2C3 minus C2B3. Now we changes the sign of the middle term, that is plus B1 if we take negative or minus. So minus B1 into, so here we change the sign, that is A2C3 minus C2A3 plus C1 into A2B3 minus B2A3, that is equal to 0, because the denominator if we take the denominator into right side, so the value is 0 because it's multiplied to 0. Okay. So now we can convert it into determinant form. That is, if you can write determinant of A1, B1, C1, A2, B2, C2, A3, B3, C3, that is equal to 0. So if we check this value, if we expand in R1, that is A1 into B2, C3 minus C2, B3, minus B1 into A2, C3 minus C2, A3, and plus C1 into A2, B3 minus B2, A3. So this is the procedure in determinant form to evaluate the system of a equation. Okay. Now take an example here from your Elements of Mathematics book of Elements of Mathematics, page number 139. We can take an example. We can take an example or in our books, question number 15. The question is eliminate x, y, z from A is equal to x by y minus z, B is equal to y by z minus x, and C is equal to z by x minus y. So this is a very important questions having 4 marks category in CSG mode. Eliminate x, y, z from the 3 equations. So now we have to write in a correct procedure. That means the first equation is A is equal to x by y minus z. So now we have to multiply this expression that a y minus a z is equal to x. Now we have to arrange in a systematical order. That means first we write x, y, and then z. So here minus x plus ay minus az is equal to 0. So this is the question number 1. So we have to arrange them in a systematic order. That means x, y, and z form. And the second one is b is equal to y by z minus x. Similarly, you can write bz minus bx, that equal to y. And if we arrange them, minus bx minus y plus bz. That is equation number 2. Here also we arrange in systematically order, that is x, y, and z form. And the third one, that is c is equal to z by x minus y. Similarly, you can multiply here cx minus cy is equal to z. That is cx minus cy minus z equal to 0. So this is the equation number 3. Now we have to evaluate x, y, z because there are 3 variables x, y, and z. So eliminating x, y, and z from equation 1, 2, and 3, we get, as we know in previous elimination of method, that is determinant of these 3 expressions. That means we can write here determinant of, if we eliminate x, y, and z from 3 equations, that the coefficients are minus 1. So a coefficient of x are minus 1, minus b, c. So here we can write minus 1, minus b, and c. and the coefficient of y, that is a minus 1 minus c, a minus 1 minus c, and the coefficient of z, that is minus a b minus minus 1. So determinant of this term is equal to, we have to compare 0. Now we have to expand to get the result. So here minus 1 into 1. So we expand along first row, that is minus 1 into 1 plus BC minus A into B minus BC. Okay. And the third one, minus A into BC plus C. BC plus C, that equal to 0. Now we have to multiply, so we get minus 1 minus BC minus AB plus ABC minus ABC minus AC, that equal to 0. So here answer is an expression ABC. So we get minus A minus BC minus AB minus AC, that equal to 0. So this is the answer, but we can multiply minus, so we get the result 1 plus AB plus BC plus AC, that equal to 0. So now here we have to eliminate x, y, z from three equations to get the result 1 plus AB plus BC plus CA, that equal to 0. Okay, so this is the question number 15. Question number 15, and in your book that contains page number 139. Okay, now take another examples. There, question number 16. Cx is equal to cy plus bz. So first we have to arrange them in systematical order. That is x minus cy minus bz is equal to 0. That is question number 1. And the second one, that is y is equal to lz plus cx. If we arrange them, minus 3x plus y minus az is equal to 0, that is equation number 2. And the third one, that is z is equal to bx plus ay. So here minus bx minus ay plus z is equal to 0, that is equation number 3. Now we have to evaluate x, y, z from these three equations. So eliminate x, y, and z from equation 1, 2, and 3. We get determinant of coefficient of x, y, z is equal to 0. That means the coefficient of all these three equations, that is 1 minus c minus b, 1 minus c minus b, and the coefficient of y, that also minus c, 1 minus a, and that is minus b minus a1. So here now we have to expand. So 1 into 1 minus a square plus c into, because we have to expand in first row method. So c into plus cy, write into plus c, that is then this is the sign because it's plus minus plus. So here we write plus c into minus C minus AB minus B into SC plus B that equal to 0. So if you multiply here 1 minus A square minus C square minus ABC minus ABC minus B square that equal to 0. So here we can write in the systematic order that is minus A square minus B square minus C square minus 2ABC that equal to minus 1. So if we multiply minus 1 both sides or we take common minus, so we get A square plus B square plus C square plus 2ABC that equal to 1. And this is the method, or here you have to prove that. So here you get the result that is A square plus B square plus C square plus 2ABC is equal to 1. And this is the question number 16 from your exercise determinant of x and page number 139. Similarly, you can solve question number 17 using this elimination method. I hope all these lesson will learn. Have a nice day.